Hi, I'm Daniel Rosenwasser, a program manager on the TypeScript language here at Microsoft. In this video, I'm going to talk about some of the new features that we've shipped in recent versions of TypeScript. TypeScript has been releasing at a relatively rapid rate, so when we think about new features, we're not necessarily just talking about the latest version. While we've released TypeScript 2.6 pretty recently, we've got awesome features going back to TypeScript 2.4 as well. More than we probably have time to talk about, but we can go over some of the highlights. Specifically, we'll go over weak type checking, string enums, and strict contravariance checks on parameters. One of the great new checks in TypeScript 2.4 is called weak type checking. A while back, TypeScript introduced excess property checking for object literals. Basically, when passing an object literal to a type that didn't expect a specific property, TypeScript would provide an error on that excess property. This was useful because it was often the case that users were accidentally misspelling optional properties that were actually expected. For instance, in the example, you can see that we misspelled color with a U. However, this check only protected against object literals. It didn't protect against other random types. For instance, I could still pass a number to something and expecting a type with all optional properties. In TypeScript 2.4, we tightened a few of these checks up with what's called weak type checking. Basically, any type with all optional properties is considered weak because completely unrelated types can often be assigned to it. When a type is weak, assigning any object that has absolutely no overlap with that type will get flagged as an error. This can catch a huge number of errors that would have otherwise silently failed. So now, passing in something like a number or a function will trigger an error. Another great feature from TypeScript 2.4 was string enums. Typically, we use enums as well-known constant values that can be used symbolically throughout our program. We can easily find all references or rename these declarations as we please without worrying about changing the semantics of our program. But a common problem with enums as they exist today is they don't serialize very well. When communicating over different protocols or just debugging, the problem with traditional enums is that they just appear as numbers. While it's fine for computers, it's kind of tough for humans. That's why with TypeScript 2.4, we've introduced string initialized enum members. As you'd expect, these enums work mostly the same as numeric enums, but instead of opaque numbers, you can finally understand what your program is talking about at runtime by giving a useful string representation. The only caveats are that string enums don't get a reverse mapping to look up the enum name from the enum value, and that string enums always need to be initialized. Finally, we can start talking about strict variance checks for function types. Let's say that I have an animal type and a dog type that extends animal with its own properties. Let's also say that I have a function g that takes animals and returns any, and I have a function f that takes dogs and returns any. Now, if I wanted to see whether f is assignable to g, I might be tempted to just check whether every respective part of f is assignable to every respective part of g. So I'd naively think that if the parameter dog of f is assignable to the parameter animal of g, then f should be assignable to g. But actually, we need to think more deeply about how assignability implies substitutability. If f is assignable to g, it means that it should just be okay to say that f takes an animal just like g does. But that's not the case, because if f uses anything specifically from dog, then we might get a runtime error if any other sort of animal like a horse, a giraffe, or an elephant is passed in. It turns out that the correct thing to do is actually to check for assignability in the opposite direction. So to see if f is assignable to g, we have to see whether or not g's parameters are assignable to f's. This switch in direction is what we're referring to as a contravariant check. Historically, TypeScript has checked in both directions to allow for certain JavaScript patterns, which can be overly lax. With TypeScript 2.6, we've actually introduced a new flag called strict function types to help catch incorrect code like this. With strict function types, TypeScript will appropriately flip directions when checking parameters on most function types, the exception being when we compare methods from two different objects. So in our example, TypeScript will check whether or not animal is assignable to dog and give us an error. It might sound like you've never run into this or you'd never run into this, but it may be more common than you'd think. For example, with strict function types, it's surprisingly easy to map over an array of strings and numbers with a callback that only accepts strings. Strict function types helps harden your code against these sort of mistakes and can report an error when we incorrectly pass these functions around. Well, unfortunately, that's all the time we've got for today, but you can always keep a close eye on what we're doing. Check out our website at typescriptlang.org. To keep up with our new developments and releases, you can subscribe to our blog or follow the TypeScript Lang account on Twitter. And if you want to hear about the latest and greatest developments from our team, you can check out our project roadmap on GitHub. Thanks so much for tuning in, and I hope you enjoy all the great new features we've been shipping in TypeScript.